a horizontal clothesline is tied between 2 poles 20 meters apart. When a mass of 1 kilogram is tied to the middle of the clothesline, it starts a distance 4 meters. What is the magnitude of the tension on the end of the clothesline? Use G equal to 9.8 for gravitational acceleration. Okay. Let's draw the diagram. So we have a clothesline between 2 points. Say this one. Okay. And this is 20 meters. Okay, it's the length of this one is 20 meters. And we put a mass of 1 kilogram and we tie it in the middle of the clothesline. So let me pick, say this is the middle, and it starts 4 meters. So it will go down here 4 meters. Let me say this one is the mass of 1 kilogram. 4 meters, so it go down. This is a right triangle. The length of this is 4 because it's going down 4 meters, and each of this is 10 meters because the clothesline is of the length 20. This is 2 poles we have here. So now we have these 2 tension. So the 2 forks here, T1 and T2, going up. Let me call it T1 and T2. Because this point is exactly in the middle, the length the same, the angle must also be the same. Let me call it theta. Theta. Okay. The magnitude of the tensor vector T1 and T2 must be the same. Okay, let me call it T. So let me call it T here. And that's the magnitude of the 2 vectors we want to find. Okay. We want to compute. Okay. So what is that? Let me put a x, y coordinate. So this one and this one. X, Y, O. We have 3 forks at this point. The first two we know T1 and T2, that is 2 tensor forks, and the last one is the gravitational force. Let me call it W. Okay. So the other force is W, which has, okay, we know that we have OXY plane. So we have 2 components, X and Y. But the force, the gravitational force, just go straight down there. So the X coordinate is 0 and the Y coordinate is minus mg, because the origin we choose to be this point. So minus mg. G is 9.8. So m is the mass. 0 minus 1 times 9.8, which is omega 0 minus 9.8. So 3 forks counterbalance this point. So we have T1, 3 forks, T1, T2, and omega must be 0. Right? At this point is balance. So this forks plus this forks plus this forks is 0. So forks T1 and T2 have the same magnitude. Let's say T1. T1 would be had 2 components. Let me put it here. T1 first y component is this, and x component is this. Similar 42. Let me call it t. Maybe I write another picture. So here's our picture for T1. Okay, so T1x, T1y is white. Here's x, T1y. T1, vector T1 is T1x, comma T1 white. Okay, similar for T2. So we know that T1 is, so T1x, this angle is theta. So in this right triangle, this is a right angle, this is a right angle. Let's look at this right triangle. Cosine theta equal to T1x divided by the magnitude T, right? T1x magnitude T. So T1x magnitude T. So T1x is T cosine theta. And in the other one, this right triangle, what we have is T1y, right? T1y, we do cosine sine theta. Sine theta is T1 white divided by T. T1 white is T sine theta. Okay, so vector T1 is a coordinate T cosine theta, T sine theta. Be careful with the direction as this is negative, so T1 should be minus this, minus T cosine theta, right? And T sine theta. Good. Now, what is the angle theta? We're going to compute that. The angle theta is sine theta is 4 divided by 10. We will write here sine theta is this length divided by this length, 4, 10, which is 2 divided by 5. Sine theta is arcs sine 2 by 5, where theta is arcs sine 2 by 5. So that is T1. Similarly, you can do it for T2. So T2 with this. So T2 has two components. The first component is T2 x and T2y. Here is T2 x, because this is x axis and this is y axis, and here's T2y. Vector T2x, comma T2y. And similar as before, This is angle theta. Similar as before, we have theta we know. Theta we already computed. That is a arc size of 2/5. So T2x is cosine of theta is cosine of theta T2x divided by magnitude of the vector T2 T. So T2x is T cosine theta. Okay, so let's go toward the x positive part of the x-axis. So this is T cosine theta, and similarly we have sine theta T2y divided by T. Sine theta T2y by T. T2y is T sine theta. Or I can write vector T2 is T2x, T2y, which is T cosine theta, T sine theta. And where thetas we know. Where theta given by this. So we have the two force T1 and T2. Now plug in T1 and T2 inside this equation. Let me call it equation star. Now, by star we have, or maybe I copy it. So this one is star. By star we have this T1 is this vector. This is for T1. T2 is this vector. This is for T2. T1, T2, and omega we did compute it before, which is this vector equal to 0. T1 plus T2 plus omega is 0. So vector 0 actually has two components, 0, 0. Let's do the computation. T cosine theta minus T cosine theta plus T cosine theta plus 0, which is 0. T sine theta plus T sine theta minus 9.8 equal 0, 0. So the two must be 0, right? And 0 equals 0. So we have 2 times T times sine theta minus 8.9 equals 0. T sine theta 9.8 divided by 2. T equal to 9.8 divided by 2 divided by sine theta. Okay, and this one is 9.8 by 2 by sine of the angle theta, which is this one. Okay, so this is T. That is the magnitude of vector T1 and T2. This number should be 4.6, right? 4.6 divided by this much. Okay, you do the computation divided by this much. So that is T. This gives us T1, vector T1 is, oh, they only ask us to compute the magnitude. They only ask us to compute the magnitude of the tension at the end of the clothesline, so which is T. So this be done. So magnitude of the tension must be here is 4.6 psi arc psi 2 by 5. Yep, so that's how we do it.